Hello everyone. We are going to continue again the introduction to semiconductor physics from where we have left. So, quickly revising the basics, we discussed two items, silicon and germanium, why silicon is mostly used. Then we discussed energy bands, conduction electrons and holes, and then we discussed band gap for silicon. It's 1.1 electron volt, and this is energy. We discussed charge carriers. There are two types, electrons and holes, and we know the reality of holes, that is basically absence of an electron. And then we discussed the current due to electrons and holes, and then we compared semiconductors to conductors and insulators on the basis of energy levels. Now, two types, intrinsic means pure, and extrinsic means when there is some impurity added, and that process is called doping. In that process, two types are formed. How these two types are formed and what is itself doping. Now, from here, we are going to continue our discussion. So, doping. Actually, semiconductor materials in their pure or intrinsic state do not have very much high conductivity, or in other words, they have limited number of free electrons in their conduction band and holes in the valence band. So in order to increase this conductivity, we have to add some impurity into the pure semiconductor material so that it could become extrinsic, and in result conductivity will increase. So the conductivities of silicon can be drastically increased and controlled by the addition of impurities to intrinsic or pure semiconductor material, and this process is actually called doping. When in result there is an increase in number of charge or current carriers, either electrons or holes. We will see in which type, like in N type, electrons will be increased, and in P type, holes will be increased. We will see how. So, starting with N type semiconductor is actually formed when impurity atom with 5 valence electrons are added. That means of group 5. The examples are phosphorus, arsenic. Now let's try to see what happens. Now these are silicon atoms. So within them, one atom of group 5, that is antimony, is added, and of course this is 5 electrons in its outermost shell, so there is one extra electron, and this one extra electron will act as a free or conduction electron and will actually result in extra free electrons, and because electron has negative charge, so this type of material will be treated as N-type semiconductor. So in result, extra free electrons and electrons become majority carriers. Now, when we say electrons becomes majority carriers, it means there will be again holes, not necessarily due to this doping, but due to some thermal effects, and that these holes will be in the minority carriers. So the characteristics are that In N-type semiconductor, there is high electron concentration and ultimately improved conductivity. Now, P-type semiconductor. In P-type semiconductor, impurities of group 3 are the atoms which have three valence electrons are added. Examples: boron, aluminum. So let's see what happens again. Silicon atoms. Now one boron atom. Of course, the three electrons of the boron will have the covalent bonds with the three silicon, while one will be remain vacant. So when one will remain vacant, this will be treated as a hole. And when we say hole, that means absence of electron. This is treated as positive charge. And thus, the material that is formed is called P-type semiconductor. So, in result, holes are created. If we talk about characteristics, so of course, here holes are in majority, they are majority carriers. Electron are again minority carriers. Again, we must note that electrons are not due to the doping process, they could be due to some thermal uh, due to thermal effects. Okay, so now let's try to summarize. Semiconductors lie between conductors and insulators. It means their conductivity is in between conductors and insulators. Behavior could be explained using energy band theory, and in that there are two important bands: valence and conduction band. Conductivity is controlled by doping process. Two type of semiconductors: pure or intrinsic. In extrinsic, impurities added, which results in two types, N and P type. And we know in N type, electrons are majority carriers, holes in minority. In P type, holes are majority carriers and electrons will be minority carriers. So here, this introductory part is completed, and we will continue our discussion in the next lecture with the diode. Till that, take care. We will meet soon. Bye bye.